Somebody asks the most common electrical question there is. What size wire do I need? And the honest answer is, it depends on three completely different things. And most people only ever check one. Check only the first one, and you can end up with 14 gauge wire on a 20 amp breaker. That's a wire rated for 15 amps, sitting behind a breaker that won't trip until 20. So today, all three gates. Run every one and take the biggest wire any of them demands. Start where we left off last time. A breaker does not protect your appliance. It protects the wire, which means the breaker and the wire are locked together. Pick one and you have picked the other. The number that links them is ampacity. The current a conductor can carry continuously without cooking its own insulation. Here's the baseline every electrician has memorized. Copper, 14 gauge, 15 amps, 12 gauge, 20 amps, 10 gauge, 30 amps, then 8 gauge at 40, and 6 gauge at 55. And notice the gauge numbers run backwards. A smaller number means a fatter wire. 14 is thin, 6 is thick. But those aren't the only numbers in the table. There are 3 columns, and their temperature ratings: 60, 75, and 90 degrees Celsius. 90-degree wire, like THHN, carries more. 12 gauge is 20 amps in the 60 column, but 30 amps in the 90 column. Here's the catch that trips everybody. You don't get to use the 90 column just because the wire says 90. You are limited by the weakest link in the circuit, and that's usually the terminal screw on the breaker. For circuits 100 amps and under, that means the 60-degree column, unless the equipment is listed for 75. Most modern breakers are, so check the label, not the wire. Gate 1, Ampacity. Take the same 1500 watt heater from last episode on a 120 volt circuit. Current equals power over voltage. 1500 over 120 is 12.5 amps. It's a continuous load, so multiply by 1.25. 12.5 times 1.25 is 15.6 amps. That needs a 20 amp breaker. And a 20 amp breaker means 12 gauge wire, not 14. Gate 1 says 12. Gate 2, distance, because a long wire has resistance, and resistance eats voltage. Voltage drop equals 2 times K times current times length divided by circular mils. The 2 is because the current goes out and comes back. And K is a material constant, 12.9 for copper. That's the resistance of a piece of copper 1 foot long and 1 circular mil in cross section. Run that 20 amp circuit 100 feet. 12 gauge is 6,530 circular mils. 2 times 12.9 times 20 times 100 is 51,600. Divide by 6530 and you get 7.9 volts. 7.9 volts out of 120 is 6.6%. The target is 3. 10 gauge still misses at 4.1. 8 gauge lands at 2.6. Ampacity said 12, distance says 8. Gate 3, derating. Bundle a lot of conductors into one pipe and they can't shed their heat, so they lose capacity. 4 to 6 current carrying conductors multiplied by 0.8, 7 to 9, 0.7. 10 to 20, cut it in half, and you derate from the 90-degree column, then check the termination limit afterward. 12 gauge THHN is 30 amps at 90. 6 of them in a conduit. 30 times 0.8 is 24. Still covers your 20 amp circuit. Now the question everybody actually searches: what wire for a 100 amp subpanel? Go to the 75 degree column. 4 gauge copper is 85 amps. Not enough. 3 gauge copper is exactly 100. That's your answer. 2 gauge gives you 115 if you want margin. In aluminum, 1 gauge gets you 100 and 1/0 gets you 120. And yes, there is a special dwelling rule that can let you go smaller on a main feeder. I put that one in the description. So run all 3 gates and take the largest wire any single one of them demands. Never the smallest. And the one thing to never do, 14 gauge on a 20 amp breaker. That breaker will happily pass 20 amps through a wire rated for 15, and nothing trips while it heats up inside your wall. Ampacity, distance, derating. 3 gates, 1 wire. And the breaker and the conductor are always chosen together. Next time, back to the board. Grab a pencil, and I'll see you there.